Alright, so let's go and review traverse. So like we said, traverse is how we go down a path within a tree. So you can kind of imagine it as cleaning up decorations on the Christmas tree. When you clean up decorations on the Christmas tree, there are many ways to clean it up, right? We can clean them up one by one randomly. We can clean it up one row at a time. There are a lot of different ways to clean up our decorations. So those different ways are called tree traverses. So there's a lot of different tree traversals in computer science, but the two most popular ones are breadth first search and depth first search. And both of those searches cover a different approach to searching the tree. So first, let's cover breadth first search. So breadth first search looks at each level, one at a time, and looks at each node on that level. So for example, you can see in this animation here, on the right, we see that first the top one is searched, so the yellow node shows the traversal. We can see that the first one is the 10, because that's on the first level. Then it goes to 4 and 17, which is the second level. And then finally it goes to the 1, 9, 12, and 18, because that's the last level. And there's also a picture on the left, which shows the order of the traversal here. So we can see that F is first, right here, because it's the first level, that's the root. We can see B and G are second and third, because that's the next level after F. And then on the third level here, we can see that A, B, and I are searched 4, 5, and 6. And then finally, the last level, C, D, and H are traveled 7th, 8th, and 9th.
Again, imagine Christmas tree, right? How do you take away the Christmas tree? So, assuming you have seven Christmas tree decoration. So you want to take away everything. So the order of the picking up the Christmas decoration is first is 10, 4, 17, 1, 9, 12, 18. So instead of going this way, you just go this way. That's called
one row at a time. So like one row here, then we go to this row, then we go to that row, and then we go to that row. So to do breadth first search, we have to learn about this data structure, like we covered earlier, called the queue. I can't exactly tell you why this is going to be important, but you will see in a moment. It's kind of hard to explain, but I think it's something that's easier to see once you see it work. So first, let's see what a queue is. So a queue is a data structure, like we said. Like a data structure holds different kinds of data in like lockers. So a queue is a straight line. Everything that goes in first comes out first, which is why it's called first in, first out. And you can kind of compare that to like a line at a restaurant. Whoever lines up first should go in the restaurant first, right? Whoever lines up last shouldn't go in the restaurant before someone who lined up earlier. So for example, in this picture, if this person over here gets his ramen before this guy here, he's going to get upset at this guy, right? That doesn't make sense. So this is why we have a queue data structure. It makes sure that the person who goes in first comes out first. Yeah, let's see why this is important. And the reason why it's important is because breadth first search uses a queue to go through the nodes. So let's take a minute to watch this video here to see how breadth first search works. So on the right here, we have the algorithm of breadth first search. We first start by putting the root node inside our queue. So the first node comes out, and whenever we remove a node from the queue, we bring its children inside the queue. So the children of Jack is 6 and 3. So we put 6 and 3 inside our queue. Next, we take the first node from the queue, which is 6, because he came in first, comes out. And then 6 invites his children, which is 7. Now 7 comes in. And then we bring the first node again from the front of the line, which is 3. So 3 comes out. And 3 brings his children in, which is king and pen. So again, we take the first node of the queue again, the front of the line. 7 comes out. And 7 doesn't have any children, so there's no children to add to the queue. So we move the line up. The front of the line is king. So king comes out. And again, king has no children because he's a lead. So we add nothing to the queue. And finally, we take out 10. 10 also doesn't have any children. So now our queue is empty and we are done with breadth first search. And if you look at the order of these cards here, you can see that it's in order of each level. So if you see here, now we see that Jack, which is the first level, is first. 6 and 3, which is the second level, is next. 7, King, and 10, which is the last level, is last here. So by using this queue data structure with breadth first search, we can achieve printing out the tree in order of levels.